Okay, hopefully you're able to see my slides. So just
Yep.
let me know, give me a nod
See
if there's any issues. Perfect, thank you very much. And yeah, so today we're going to talk about building reliable data lakes with Delta Lake, but obviously the start of the show is Presto. So let's go ahead and start the show here, okay? So in case you're wondering who I am and why I've decided to go ahead and join you guys here today, I'm actually a senior staff developer advocate at Databricks, longtime Brickster. Prior to that, um, actually, I've been working with Apache Spark since 0.6 and Delta Lake since its inception. Previously, I was a senior director of data science engineering at SAP Concur. And prior to that, I was a principal program manager at Microsoft for Azure Cosmos DB, Project Isotope, what is now known as Azure HD Insight, and also SQL Server. So little bit of experience when it comes to data. And so hopefully we're going to make this a fun session, and glad to chat with you all on all things, well, Delta Lake. So if you're not familiar with what Delta Lake is, it's an open source storage format that brings ACID transactions to big data workloads on cloud object stores. And it's the key ingredient for building your lake house. Now, why do I sort of harp on this concept? And in fact, I want to talk about the evolution of data management from the prospects, especially from the fact that I used to be part of the SQL Server database team. Okay. And so, oh, by the way, there's a little bit of background noise, so I'm not sure what happened there. So if you're whoever's not muted, if you can mute yourself, please. Thank you very much. And so why do we need lake houses, right? Well, let's start talking about data warehouses. So this is actually literally my historical context. Hey, let's go build a data warehouse, right? And I was part of the SQL Server team, like I mentioned before, and I helped build some of the largest SQL Server implementations that you had found. Okay, pretty sweet. Right. And we're going like, yes, let's go build these data warehouses. They're purpose-built for BI and reporting. And in addition to helping build SQL Server data warehousing itself, I also was part of the SQL Server analysis services team, right? The BI, what eventually turned into what now is known as Power BI. But basically, we were building these super analysis services queues that allow you to do like really fast BI ad hoc querying that would come back in seconds. And to provide a little context, I was actually one of the first, if not the first, Microsoft employee to present at Hadoop Summit, Hadoop World, where we had showcased the creation, this is in collaboration with Yahoo, at the time, the largest analysis services cube on the planet, right? It was 24 terabytes. The source of that cube was a 2,000 node Hadoop cluster at the time. So, a little bit of data. So pretty cool. This is awesome. We have the best BI, the best reporting, but there inherently were problems with this, right? There's no support for video or audio or text. There definitely wasn't any support for data science and machine learning. We had these schemas, these star schemas that you had to follow through. When you say limited support for streaming, that's actually us being a little too nice. Frankly, the fact is really there was no support for streaming. Certainly closed and proprietary formats, right? So, you had to actually, in the case of SQL Server or the case of analysis services, and this is similar to any other data warehouse, these were specific formats that you had to work with, right? And of course, it was extremely expensive to scale out. To give you some context, while Hadoop itself was designed very well for scaling out, when I talked about that 24 terabyte cube solution, that was a single box that basically we had to maximize to the nth degree, where we also had to go ahead and we actually had a clone, and so we actually did hardware cloning in order to be able to support if there was any concerns with downtime. And we ended up using, not my choice by the way, an Oracle rack server to be the staging server. So the most expensive staging server you'll ever see. So really, really expensive way of doing it. But hey, it gave us this great warehousing, this gave BI, and this reporting. So boom, we're done, right? Solution solved, and we're done for the day. Obviously not. That's why we created data lakes. And I was part of the Project Isotope, which is, like I said, mentioned before, as part of was the precursor to Azure HD Insight. And so we were a 9-person team that said, hey, let's bring Hadoop into Microsoft. This is during the bomber year, so that was a lot of fun when we did that, pulled that one off, okay? And because of that, hey, we got Hadoop, we got it running, so now you can do your data science, and now you can do your ML, and you're good to go. And sure, maybe the queries were slow, but if I had, terabytes, hundreds of terabytes or petabytes of data, the query could actually finish, as opposed to if I was trying to chuck into a SQL server, it would just never finish, right? Of course, standard problems with data lakes: poor BI support, complex setup, poor performance, and unreliable data swamps. And I really want to harp on this little point here, okay? This idea of unreliable data swamps, right? You hear about data salad, data swamp, data whatever, right? But the context is, we pitched the idea, and I'm guilty of that, by the way, so I want to call myself out on this. The idea that we would say, hey, you could just go ahead and solve all of your problems by simply going ahead and doing schema on read. Like, the idea was that no problem. I don't have to care about the format of the data. I just get the data, I would dump it in, go super fast, and then only at the point where I need to read the data, I could write my cool Scala code or Java code or whatever it was, and I could just magically solve the problem and we're good to go, right? And so that was the pitch that we're telling people. So just dump your data into Hadoop. We were done. You build your data lakes, and we could just magically solve the problem at read time. Now, for anybody who is using Presto, or for that matter, Spark, Delta Lake, anything else, any other of these systems, we know that that statement's not even remotely close to true, right? So what we need is, we need somewhere in between, those the best of both worlds. And that's what this concept of lakehouse really is about, right? And the reason why is because people say, well, no, let's see if I can just have one side of it that's running warehouses, and one side of it's running data lakes. So the BI would go, and reporting would go off the warehouses, but then the machine learning, data science, and real time, and that would all go off the data lakes. And you're perfectly fine, except what you're doing is that you run into basically this really messed up Lambda architecture, where you have to reconcile the data that's sitting on one side versus the other side, right? And so this is what we go back to saying, well, then really, what you need is a lakehouse, which is the best of both worlds. I'm saying I can take the transactional consistency and that I got with warehouses, but the flexibility that I got with data lakes, so I could go ahead and actually handle all the different data domains, whether it was streaming, BI, data science, machine learning, or whatever else, right? And so in order for you to build that lakehouse, this is the context here, right? It starts here. You're going like, great, we start with Delta Lake, great, which allows us to have that scalable, open, general purpose transactional data format. That's half of the solution. What's the other half of the solution? Using a high performance query engine. Of course, today we're going to go talk about Presto, but it's applicable to all the above. And that's the context here, right? That this is how you can go build your lakehouse, by allowing yourself that high performance query engine, yet also scalable or open general purpose transactional data format. Okay. So then let's dive into some of the technical details. And I love sitting here. So I'm going to pause just for a second to say, if you do have a question, I probably am not going to see it in the chat right now, because the chat sometimes doesn't show up properly, but you're more than welcome to raise your hand or turn on your camera or unmute yourself and ask questions. Glad to dive into those details. Otherwise, I will dive into the technical stuff. And again, you're more than welcome to interrupt me as I dive into those details. Okay. Cool. All right. So then let's talk about, so in order for Delta Lake to work, it's not just about your scalable storage for your data. It's also about your scalable transaction log for your metadata, the metadata that defines what's really going on with your data. We're going to talk about that a lot more in a second, okay? So in order to have scalable storage, let's talk about the good old-fashioned cloud object storage, right? This is what the vast majority of the time we're typically talking about. So the tables are stored as Parquet files on your cloud object store. This is applicable to AWS, applicable to GCS, applicable to Azure ADL's Gen 2, right? Doesn't matter. Perfect. Well, then what is a scalable transaction log? Well, in the same folder as your Delta Lake table, the path to the table, we put an additional folder, _delta_log. Inside that folder is a bunch of JSON files and then subsequently Parquet files. What is that? Well, it's the Delta transaction log. It is a scalable transaction log, a sequence of metadata files to track all the operations that are made on those files that make up your table, okay? So you store it in cloud storage along with the table, so that way it's portable. right? So in other words, if you move the table from one system to another system, just as long as you move that everything underneath that table past table folder, the transaction log comes with it. So it's portable, right? And because it's made up of JSON files and then every 10th checkpoint, it's a Parquet file, then you can read and process the metadata, which tracks all the files in parallel. And that's the key thing. So in other words, you're taking advantage of the scale, the distributed scale that you actually have a storage to scale your transaction log. That's what Delta Lake allows you to do. All right. So it's important that these transaction log commits are done as ordered and as atomic commits. In other words, they either happen or they don't. So for example, if I'm doing an insertion, like so I'm inserting new rows of data. Well, that rows of data are comprised of, let's just say, 001.parquet and 002.parquet. Perfect. So in the first entry into the transaction log, 00.json, what happens is that we record the fact that the table is now comprised of 001.parquet and 002.parquet. Perfect. Then now we're about to do an update. Okay, so an update basically says, okay, I'm going to do an update, which ends up deleting a whole bunch of files because it's a merge as well, let's just say. And what ends up happening is that we're generating a new set of rows. Well, those new set of rows make up 003.parquet. Okay. But the table now is comprised at this checkpoint 003 parquet because we actually removed 001 and 002.parquet. Now, we actually haven't deleted the files, at least not yet. This allows us this concept of time travel, which we're going to demo shortly. But the point is, then you know at a particular version or particular time, the table was comprised of 001.parquet, 002.parquet. And then at a later time, after the update completed, transactionally completed, it's now comprised of 003.parquet. That list of files that make up the table, well, in this case, 003 parquet, is included in the transaction log itself. So when any system like Presto is attempting to read what makes up that table, as opposed to it doing a file list, okay, of your cloud object store, which can be extremely slow, okay? The listing of objects on a cloud object store is extremely slow. So because of that, what it does instead is, hey, let me just go to the transaction log. In the transaction log, that list of files is already there. So in this case, the 01.json, it contains a list of files. This example is only one file, but the point is that for any large scale system, it contains a list of files. And then Presto can go ahead and actually now send its workers to go ahead and read all those different files. Okay, so that's the context. And that's why it's so important for us to have these transaction log commits. It allows us to have consistent snapshots, right? So either the reader, if it's, if the query from Presto had occurred before the update completed, it knows it's supposed to read 001.parquet and 002.parquet. But if the query, then another query occurs a millisecond later, but that means the update, this is at a point in time where the update had completed, then you actually will, for that query client, for the second reader, it'll actually say, oh, I'll read 003.parquet, right? So in other words, no dirty reads, right? There's nothing in between. Either you've got the, when you query the table, you know exactly which transaction it's referring to at that point in time of the query, and then you'll know exactly which files that make up that table at that point in time. Okay. There you go. Okay, sorry. So because it's so important for us to provide ACID transactions, the whole context is that we're doing it via mutual exclusion on the log commits, right? Basically what happens is if they're concurrent writers are trying to write to the same table at the exact same point in time, you actually have to agree on what the order of those changes are. Now, we typically follow optimistic concurrency control, meaning that most of the time we're hopeful that in fact, these writes will actually not interfere. That's the idea of optimistic concurrency control. Why do we allow for that? For example, if there's one writer that's trying to write to one partition, but one writer that's trying to write to another partition, Under optimistic concurrency controls, that's perfectly fine. They're actually not interfering with each other. They're writing to the same table, but they're writing to different partitions, so that's not that big of a deal. Okay, but when they do, how about if they do write and they're both trying to write to the exact same partition, even under the guise of optimistic concurrency control, one will fail to complete because of the fact the other one actually takes precedence. And this is what we say the concurrent writers need to agree on the order of those changes. So for example, writer one is going to go ahead and writing to the initial transaction log, 00.json. Writer two, no problem. It says, hey, no, well, I'll do my writing insertions. It'll go to 001.json. So far, so good. But how about if they're both trying to do updates or insertions or whatever else to the same partition, to the same table? Well, then what happens, writer two and writer one are going to fight with each other to say which one gets to commit. And in this case, only writer two wins. This particular example, writer one would fail. The client, depending on and this is included within the Delta transaction protocol, the client will then get to auto retry and see if it works in different scenarios. If for sake of argument, you're trying to do an update and the data has changed, the reality is that you most likely will have to fail, allow the user to recognize, hey, the data is different since when you ran it, you might need to do something different now. Versus if it's just an insertion, then it probably actually would not interfere with each other at all. It'll just automatically retry and to do the insertion. Okay. So far, so good, everybody? Cool. All right. So because we rely on these cloud object stores, or for that matter, HDFS. So in other words, we're leveraging the scale of these storage systems. The whole premise is that even as we're doing all of these things, there isn't a single point of failure. That's the whole purpose of working with S3 or ADL Gen 2 or GCS. It's a scalable infrastructure. So there is no single point of failure. It's not like a single node disk that could fail. You're writing to cloud object stores, right? So in terms of storage support, which allows that concurrent writes, now, S3 has always allowed for concurrent writes, by the way, with Delta Lake, but it's through a single driver. With multiple drivers, HDFS, Azure, GCS has the mutex, specifically put if absent consistency guarantees out of the box. So it never had that problem. S3 does have this issue so that means if you have two different drivers trying to write to the same table at the same time, because S3 lacks put if absent consistency issues, you could potentially corrupt the data. Okay, this is a problem for any system that's running the S3. Now, how most of our systems have solved it, including how Delta has solved it, is that we use DynamoDB as a lock store, not log store now, lock store. So in other words, who determines who gets to lock the transaction log at that point in time? So that way we can ensure that it is done in the proper order. And so we're not sure when the put if absent guarantees are going to be added to S3. We've had discussions with them for quite some time on this one, but nevertheless, included in was it last month or the month before when we released Delta Lake 1.2, it actually included the DynamoDB S3 multi-cluster writes. And we actually recently blogged about that as well too. So in the end, this allows you to not have a single point of failure for any of these systems. Now, what makes Delta Lake unique? I'm not going to dive into, I'm going to keep it relatively high level because I don't want this to be just a marketing pitch. I want to show you a demo. I want to dive into some of the details. But like I said before, Delta Lake, the key features include the fact that we're talking about ACID transactions. It protects your data with the strongest level of isolation. Because of its design, it was designed to handle scalable metadata, handle petabyte scale of data with the excessively large sizes of metadata that often goes with it. You can, because of time travel, you're able to access and revert to earlier versions of your data for audits, rollbacks, or reproduction. And this inherently also allows you to actually have your audit history to go with it as well. One of the main reasons we built Delta Lake and recognized that was because it's unified batch and streaming. We had so many customers from the community that were running into issues, and this initially, coming from Databricks, initially it was a lot of these Spark writers, right? Well, they're trying to do Spark structured streaming and Spark batch, writes and queries all at the same time, and they basically were end up like leaving a lot of orphan files due to failed writes for whatever reason. So with a transaction log, we can ensure that either the write happened or the write did not happen, right? It's atomic. And so it allows us to basically run those batch and streaming concurrent writers and readers all at the same time without running into too much trouble, which is pretty sweet, okay? In the process of doing that, we do support schema evolution and enforcement. So in other words, if you have a table and it says it is comprised of these 5 columns, we can either enforce it. So if another set of files or of data that's trying to be inserted in the table has decided to add a 6th column, we can enforce the schema and say, nope, you're not allowed making changes to that table. Yet at the same time, you can tell the table during that query, no, we're actually going to allow the schema to evolve based off this fact. So no problem, go ahead and go do that. Other things include constraints and generated columns. So that way you can go ahead and partition using a generated column. For example, off the most common approach is to say your data comes in as a timestamp, but you really want to partition not by the timestamp, but maybe like the day, day, week, month type of scenario. Well, then you create a generated column to go do that instead, right? And then the DML operations are applicable to Scala, Java, SQL, and includes merge, update, delete, and all these other things. So Delta Lake allows all those capacities, right? And so with the context of with Presto, what we've done is we've started with the Delta standalone project, which allows you to automatically read the metadata that makes up the transaction log. And then subsequently, Presto then is able to read that metadata from the transaction log, and then its workers are able now to go query, read directly from those Delta tables natively. In the past, we actually had to go ahead and use a manifest file. That's great, being a little sarcastic, honestly, if you were okay with making changes to the manifest on an hourly basis or on a very slow basis. But if you are dealing with streaming and batch all running at the exact same time, that's actually problematic, to put it lightly. Well, then yes, there you go. That's why we want to make sure Presto had the ability to query the Delta tables natively without actually worrying about updating manifest files. Okay. Oh, sorry, I'm hearing a little bit background noise. So if you're not muted, could you please mute yourself?
There we go. Okay, I'm muted. Yep.
Okay, thank you. Perfect. All right, so Delta Lake, there's a fast pace of innovation. Do not worry, I'm not going to ask you to read it, but the point is that we open sourced Delta Lake back in 0.1 back in 2019. December 2021, we released 1.1. We recently released 1.2. So we're constantly, continuously adding more and more to Delta Lake as we speak. So, and like I said, just released. With Delta 1.2, this was maybe a month ago now, but basically data skipping with column stats is included now. The S3 multi-cluster writes that I referred to before is included. Compaction of small files with the optimize command, restoring to a previous version using the restore command, renaming columns. What's also being added to the roadmap, and this is what we're targeting for Delta Lake, the next version of Delta Lake, which is going to be targeting around the end of June, because we have the DATA+AI Summit that's coming up, which, hey, a bunch of the Presto folks are going to be coming to the DATA+AI Summit too. So please do join us there, whether you want to join us physically or virtually, physically in San Francisco, virtually. I'll have a slide at the tail end of this, which actually gives you a promo code as well. But included is the not just the optimized, but now the optimized with Z order as well. So we're actually including that capacity as well. That's being targeted for around Q3, I believe, right now. And we're also including generate change data feeds as well as drop columns. So we have a lot of really cool things that are still in the woodworks for us. And so hopefully you're able to go ahead and dive into those details. And so let's see. Oh, okay, before I go into the demos, I just want to say, look, Delta Lake covers many different cloud platforms with many different APIs and languages, with many different engines, SQL engines, and many different ETL and streaming engines, right? So it is a system that has a very broad integration or connector system that's really cool for you to work with. So So by all means, please go ahead, and if you have any questions about any of these things, you're more than welcome to join us. We also typically have Delta Lake community office hours every 2 weeks. In fact, the next one's this Thursday, I believe. So that way you can the community can definitely ask us any questions. And so what were some of the key native connectors? The one we're going to show right now is the Presto one, which includes a Delta reader, which was initiated back in Presto DB 0.269, which is pretty cool. All right, so let's see. Let me switch to demo mode, and then I'll probably jump a little back and forth. Okay, so all right, so you're all familiar, of course, with this view. And in this case, thank you, Rohan, for letting me actually leverage HANA to go ahead and run the queries against, just because it allowed me to make my life a little bit easier. I'm going to go ahead and switch screens to the terminal now in that case. Oh, sorry. Stop sharing. All right. Perfect. So here we go. Everybody's familiar with the good old-fashioned Presto. So I've already connected to that environment that Rohan had already set up. And so you notice that the catalogs here, basically, I've got multiple schemas that I can work with. I'm going to specifically go ahead and, oops, sorry. I'm going to specifically query this available schemas within for Delta Lake. Okay, so far so good. And by the way, if you're wondering, I'm doing a little bit of switching back and forth, so apologies for doing that, but I figured it was easier. And I've got a very large screen, so I don't want to go ahead and show my full screen, because then usually nobody can see anything. But basically, if you go back to this here, then you can basically see that the queries came through perfectly fine in my Presto cluster right here. So no problem. So I'm going to go back to my terminal here. There we go. Boom. All right. So what's next in our doc? All right. Let's see. Let's show the tables from. And as I'm running these queries, by the way, you're more than welcome to ask any questions. Again, you can unmute yourself. You can put them in chat. So I'm going to specifically take a look at the customer part table. So let's see what's inside there. Okay, so let's definitely take a look at what's inside this table. So I think it's running a little slow today, but only because I think Rohan, we probably had set up using spot instances, so our own bad on that one, didn't we? Nevertheless, it's currently running right now. And so as we're running for the demo, again, any questions, any thoughts, anything you'd like to go ask, this is the great time to do it right now.
So Denny, this is Pratyaksh, and I have a question about the querying part actually. So what I want to ask is, when suppose Presto is trying to query any delta table, so is it only reading the latest latest JSON file from the transaction log, or does it read all the files from the transaction log?
Oh, that's a great question. So in the end, what it typically does, it'll actually put in memory all the transaction logs, but what it does, it looks at the Parquet files and they're up to the last 9 JSON files. This also denotes the fact that basically, because when you have the 10th one, that becomes a Parquet file again. That's why, okay? The reason it does that is because that way it actually has the full historical context of what the table is. Now, saying that, if you only query the last JSON file, right, then what ends up happening is the list of the files that make up that table are comprised inside there. So exactly to your point, you can just theoretically go do that. That's actually how we generated the manifest files themselves initially, right? And so when I'm running right now, this query, for example, this query here, okay, where I'm querying the table and I'm just looking at, I'm just querying what the results in it. What it's doing basically is looking at the last JSON file to get what is comprised of that table, and then go ahead and have Presto go query the files that make up that table, basically. Make sense?
So Denny, I think I lost you in between. So you mentioned something about the last 9 JSON files or something like that.
Correct. So basically, when we make up the transaction log, there are multiple JSON files that make up the transaction log. But of the 10th file, there's a checkpoint that kicks in. That checkpoint basically goes ahead and says, okay, take the previous 10 JSON files and go ahead and make it into a Parquet file. So that way, if your cluster crashes, as opposed to trying to iterate through all those JSON files, it can just iterate through the Parquet files. That's the context. Make sense?
Okay, so like, how did you come up with this number 10? Like only 10 files? Like, why not any other number? Let's say, like, is there any logic behind that? Let's say we could go with 15 JSON files or some other number also.
Honestly, it was relatively arbitrary. I mean, it was just basically the fact that we knew that we didn't want to have that many JSON files because it would slow down the reading of the metadata. It would slow down the reading of the transaction log. So that's the reason why you definitely want to definitely would want to go ahead and be able to do that, basically. So we just arbitrarily chose 10. That's really it.
Okay, so I think there must be some archiving logic also behind controlling the number of JSON files in the transaction log.
That's correct. So specifically, there's a command called vacuum that you can execute that basically clears up any old files, whether it's data files, i.e. Parquet data files, or your JSON files. And so the idea is that by default, you when you run a vacuum on its own, it will clear out the last, anything that's older than 7 days for data and anything that's older than 30 days for logs. Now, the key important thing, it's not removing, if you've got data from like 5 years ago that's inside there, okay, it's not removing anything that's 5 years old per se. What it's doing is removing any previous versions of that table, okay, that's 7 days or older, right? And so in order to reduce the number of files that are in your storage, whether and that's both your data files and your transaction log, that's the reason why you want to go ahead and clear that out, right? And so, but there are plenty of people that actually leave that running for an extended period of time. Now, in batch scenarios, I think that's perfectly fine, but in streaming scenarios, I would definitely not advise that. I would definitely advise to clear out these things. Yeah, make sense?
Yeah, that was helpful actually. Thank you, Danny.
Sure.
Yeah.
No problem. So, for example, I'm going to go ahead and run this query, and I'm also going to answer Dennis or Denise question here, okay? So I'm going to run a quick query just to get the count of the table right now, okay? And so to your point, basically, right now it's going to the most recent or the last JSON file to determine what makes up the files, and it basically is going to go query it, and it's going to come back with the results. So it is currently planning right now and running, and so like I said, it's probably a little slow today. So my apologies for that. Saying that, Dennis or Denis, you've asked the questions. As far as you know, the views are not supported by the Delta catalog. Are there any plans to support views? In fact, yes, there are plans. It's just not currently as high of a priority in comparison. So one of the things I would ask you to do, though, is if you can go ahead and actually create a GitHub issue on the Delta Lake GitHub, and then that way people can vote in on this one. Because my take on stuff like this is that it's a lot of the asks we do it based off of what the community feedback is. And so right now there's been massive asks for like dynamic partition overwrites, S3 multi-cluster writes, the change data feed capabilities, and so forth and so forth. So we've been focusing more on that. So it's less of a we don't want to do it, and much more of a what is the community asking? Then this is what we together are working on. Now, just to finish up this query here, I did want to call out that basically, okay, when I query the customer table, I'm saying, hey, currently has about what 2 million. That's right, 2.6 million rows inside. Okay, so excuse me, no problem at all. But what happens if I go ahead and query an earlier version of this table? Well, all I have to do, of course, when I run it, that's when it fails. Oh, right, sorry. This is what happens when you start doing live queries. Haha. There you go. There you go. So in this case, I'm taking the same query that I just specified, but I'm actually now adding this at v1. This tells me the version of the table. You can actually also specify the timestamp, but it's easier to write when I just use the version number. So that's all I'm just going to go do. But the context basically is that by adding that @ sign, I can basically choose the version of the table. There are multiple versions of this table. So right now it's currently querying not the current version of the table, but the second version, right? Because v0 is the first version of the table. So the second version, v1 of that table, is actually going ahead and being queried right now. So this will come back and it'll be a much higher number, because what happened is that in between version 1 and the current version of the table, we basically deleted that table as well, deleted a bunch of rows from that table. And so back to your initial point about like the vacuuming, what happens is that if the version 1 of this table is really, really old, okay, like, and it's like it's older than 7 days. Let's just say it's like yeah, it's older than 7 days. It is possible that when I run the vacuum, that I'll delete the files that allow me to calculate the fact that there are 15 million rows inside that table, because we no longer need that. Now, you can change the settings of vacuum so that way it'll actually go ahead and instead of being 7 days, maybe being longer. And there are other options that you can potentially do, whether you clone the table or generate a new table based off of the previous information, so that way to get specific versions if you wanted to. So there's definitely other options in play, but the idea is that if you don't want that table to grow too much because you don't care about the old history, then you can run vacuum to basically clear it up. So as you see, that's pretty cool. So now, in this case, because I've got multiple versions of the table sitting in here, I can basically just specify, for example, I want to specify version 5, I can see the number of rows that's inside there as well. So this is the ability to go ahead and look at the different versions of the table will significantly make things a lot more performant, basically. So. And yeah, to follow up with the question about the Delta or Presto repository with the views actually, part of the problem will definitely be in the Presto repository, but part of the problem is actually in the Delta repository. So remember the part of the reason why I'm saying part of it's Presto, part of it's Delta, is that what is normally Presto does is, right, it says, hey, let me look in the repo on the catalog, and it'll have it'll tell me the initial location of the table. So I specify the table name and it'll tell me the base location. That's great. But what it also does, it'll also go ahead and often tell me other pieces of information. Well, in the case of Delta, we don't want that, actually. We only want you to go ahead and specify the table name, and it specifies the table path. But then subsequently, it'll go ahead and use the Delta standalone project, the Delta standalone reader, to go ahead and say, okay, now Presto is making use of that to say, okay, I have the name, it tells me the path. Now with the path, go ahead and query that information. And so what it's doing is reading the transaction log to get that information. So that's why I'm saying part of the problem when it comes to view will definitely be on the Presto part in terms of saying, hey, Presto, here's a view. The view is comprised of what? A bunch of select statements, let's just say, that are at query a table. Then that table itself now needs to be translated into how do I query that from the standpoint of Delta, which is to, for example, work on the query path. So using a very explicit way of showcasing this idea, instead of me specifying the table name, I can literally specify the path. So instead of going select star from delta.delta.tpch SF100, I'm saying, no, just give me delta.path. So you actually specify like this $path, okay, .s3. So this is actually an S3 path with files that are inside that. Now, this is an extremely small table, but the whole point is that you don't actually even need the catalog to be able to query the Delta table. You can just query it directly from the path. And so this path that you're seeing here, in essence, is what's actually inside the Presto catalog. And so, so that way, when we specify Delta, got it. Go ahead and simply give me the initial path. Tell the Delta standalone project to go ahead and get the metadata from there, because the metadata would be in S3 Delta glue test1 sample table _Delta _log, right? That's the context. And so in the end, this is the quick call out I wanted to show you about how pretty cool the Presto Delta native reader is. And so you're able to go ahead and make sense of it, and to be able to query it, to be able to run natively without actually going ahead and running a manifest file. Okay, so and Rohan asked a wonderful question. Let me go ahead and switch back to my slides, because I did have a couple more things to show before I go back. And oh, by the way, here is back to thank you again, Rohan, for the Ahana cluster that allows me to showcase all the queries that we're running and all the active workers and so forth, so forth. And is there a survey coming up for 2022 for users to request new features or provide feature feedback? Yes, we will be having a survey. We're probably targeting around August or September. For the next Delta Lake survey. You'll get free t-shirts, by the way, free swag when you go ahead and fill out the survey. But between now and then, like I say, you're more than welcome to go ahead and ping us in the GitHub issues and get all that information from there. Okay, saying that, I did want to finish up to talk about, like, here's the context for the incredible scale of Delta Lake. We're talking about more than 450 petabytes of data processed a day. In Databricks alone, it's 75% of the data scan is all on Delta, and there's more than 5,000 companies in production that are running on Delta Lake, which is pretty cool. Oh, sorry, there we go. So how do you engage with us? Just like I've been sort of calling out before, you can go to delta.io. We have the Delta User Slack, the Delta Lake YouTube channel, the Delta User Google group. Definitely ping us in the Delta Lake GitHub issues, the Delta Lake LinkedIn, and or Data and AI online meetup. So there's lots of ways to engage with us, and that I didn't even include our Stack Overflow tag as well. And then, like I said, we have community office hours or AMAs every 2 weeks, right? So for example, this one that I just posted here is from February 17th. Why? Because I wanted to call out a cool appearance by Apple's Dominic Brzezinski, who's been involved with Delta Lake since its inception. In fact, there's a cool story about him and Michael Armburst getting together during Spark Summit 2017, specifically to go ahead and work on what ended up becoming Project Tahoe, which itself became Delta Lake. And so, like I said, how to use Delta Lake to go back, you make use of the stuff. So the key thing I did want to call out is that not just for about Delta Lake, there's plenty of sessions from Presto, from our friends on it as well too, for Data and AI Summit, which is at the end of June 27th to 30th. It is a hybrid format, so you're more than welcome to join us from virtually, or if you're in San Francisco, you're more than welcome to go ahead and join us physically there in San Francisco. But if you're going to join us physically, sign up soon, because actually tickets are running out. Now, saying that, I do have a code here, this DAISCOM25 for 25% off of conference off the conference pass and of training as well. So, of course, I should spell better, but nevertheless, that's the context. So that's it for me today. If you have any questions, I've got probably like 5 more minutes to answer questions, but hopefully, at least I've made a pretty cool showcase of Presto and Delta Lake together.
Awesome. Denny, what a great presentation and demo. Appreciate it. Thank you so much. I don't know if somebody's raising their hand because they have a question. If you do, you can unmute yourself, or you can put it into the chat, and we can ask.
Yeah, so this is Surya, and I have a couple of questions here. So right now we are using the open source version of Delta Lake. And so what we're trying to do is we are trying to get the data, incremental data from Kafka, and then we are merging that data into Delta Lake, which has millions of records, right? So what we found out was initially when we start the process, when there is no much Delta log, the merge process takes about 12 seconds or something, right? And later on, when the Delta logs increases, the merge process keeps on increasing. The 12 seconds will turn into a 60 seconds after 2 weeks of time, right?
Sure.
So we are also running this compaction process where we merge out the smaller files into a larger files, and and also we run the vacuum once every day. Is there something else we can do, to optimize this? We also have this partitioning on the Delta Lake as well. Okay,
so without rat holing, I'm actually going to answer your question, but I also want to be, I want to give you the shorter version because the longer version is going to take up like much more time. But basically, one of the things I definitely would do, definitely chime in on the Delta user Slack. All of us are actually there answering questions exactly like the one that you've asked. Now, specifically because you're running a merge as you're writing into it, the fact is, it really depends on if the merge is actually looking at all the historical data or only at the current data. Okay. If you're looking at all of the historical data, candidly, there isn't much you can do except for increasing the number of workers that are involved in order to be able to handle the load that's coming in, because of the fact that you're going back to historical data and making changes, whether it's an update, delete, or whatever else included with that. Now, saying that, are there ways to, for sake of argument, increase the number of workers, even if you're not increasing the number of nodes, or if you're able to go ahead and partition slightly differently? These are all definitely in play that can help things out. The other thing to note is, as you're debugging, is that you want to figure out how often the merge is happening. Okay, if the merge is happening, for sake of argument, specifically within the context of the current day's data, but there actually isn't that much, because it's not looking that much in history, what I'm inclined to say is that you probably want to run the vacuum more often than just once a day. Okay, in those typical situations, what you want to do is you probably even want to set up a second cluster. It's small. There's probably even just a single node, honestly, which will simply go ahead and vacuum up the files to decrease the number of both logs and also the actual data files, thus reducing the sizes of everything such that your merge can run faster. Okay, so like I said, that was the short version. There's a longer version that probably really needs to understand how to debug your scenario a little bit better. So it's not that, like, I just because I do want to answer a couple other questions, but by the same token, like, definitely make use of the Delta user Slack, because those type of questions which will allow us to sort of dig into those details. It'll be a lot easier for us to go to dive into those scenarios, if that's okay with you.
Yeah, that's fine. Do you mind pinging me that Slack channel in this chat message?
Sure. Actually, let's do it. Go to delta.io/. Yeah. Cool. There we go. Okay.
Thank you.
No problem. And Denis, so after adding Z order support to Delta standalone, will it work for the Delta connector? Yes. No, it will not. That is not the only thing that needs to be done, right? So there are parts of it will be done by basically Delta standalone, because the way Delta standalone works is that it'll actually give you better metadata to basically, so that way you're scanning a lot less files to work with. Okay, so that's great, but there's still the context of, now we're working with the Presto community to say, okay, well, how do you make use of the column stats, the files that are to be scanned, and which is basically built in within Z order, that you basically need to go ahead and work with. So this is definitely, again, a two-parter. There's parts of it that we can definitely do in the standalone, but there are parts of it that we actually definitely need to go do with the Presto community. Hopefully that answers your question on that one as well.
Hey, just out of curiosity, while we wait for another question to come in, who's using Presto with Delta Lake today? If you want to just do like a quick virtual hand raise, I'd be interested to see how many folks today are using it, or maybe thinking about using it. So Surya, we know you are. Okay, cool. Dennis is awesome. Okay, good. It's good to see. And hopefully after this, even more. Cool.
Definitely,
right.
yeah. I mean, like I said, definitely ping us on the Delta user Slack. I just prompted there if you have any other questions. We love working with the Presto community, and we hope to see more of you involved, so that way we can go ahead and work on more features together faster. So absolutely.
All right, well, I think that's it. Looks like we don't have any more questions. So I will reiterate 2 great events coming up. We hear the Data and AI Summit. So a ton of great sessions around Delta Lake. And I think there's a few Presto ones in there too, which is cool.
Right.
And then PrestoCon Day, fully virtual, happening in July. So we'll love to see folks at both of those. I think it's a great crossover between the 2 communities. And with that, Denny, thank you again. Awesome presentation, great demo, super informative. Looking forward to seeing what folks do with Delta and Presto in the future. And folks, we'll see you at the next meetup. Take care.
Thank you very much.
Bye.
Thank you.